I'm going to talk today about COBOL and where it came from and why it's important and how it is I came to be using it, or rather helping it to be used. This slide represents 3 orders of magnitude of change. As Edgar Dijkstra observed, that is the amount of difference between the speed of a crawling baby and a flying jet. COBOL embraced all of this change while imposing no requirements on the user. Everything that changed back here, from drum memory to core memory to transistors, from card punch to online printers to TCP/IP networks. Indeed, even then, you have an issue, and that's how we make our bread and butter. We're using that company to try to carry out a secret plan to take away IBM's mainframe COBOL business, and that's how we came to be, to create COBOLWorks and join the GCC effort. When we began the effort, the question was where to begin. We had to decide how to write a compiler. I don't know about you, I've never written a compiler before. And now that I've done it, I recommend you don't. It will be your life's work. We began working with the GNU COBOL compiler, which is in many ways more flexible and more competent a compiler than ours is, because they want to be. They want to be able to accept all forms and all flavors of COBOL. You're used to a standardized language where there might be one implementation, as there is in Python, or a committee like with C++, where there's such a thing as a standard form of the language, and the standard matters. I haven't found 2 places with the same COBOL yet. And GNU COBOL has worked to accommodate that. The GCC effort is more targeted. We decided that the bulk of those COBOL applications still run in IBM mainframe environments or emulations of those environments, and that we would target the ISO definition of COBOL, even though you're completely aware there is no ISO COBOL compiler and therefore no ISO COBOL application. So how would we build a compiler? I had some modest experience with the Clang project, and we ultimately, I decided that from my point of view, GCC was the best organized system for adding a front end and for joining a compiler effort. Certainly GCC, if it's not the only, has the most number of different kinds of languages that it compiles. It has the best, I would say, best framework for separating the question of the parsing and the building of the abstract syntax tree from the question of optimizing that tree to generating the machine code. It's been my experience that it is a group of excellent, friendly people, just like here, and really a wonderful project to be part of. This is how the system works. It's a little more complicated than that. So here is the separation of the different languages, which is how GCC is organized. And here's our part of the problem. We say it's a compiler, but it's not really, or it is, but it's more than a compiler. In the middle of or surrounding the compiler are all the other parts you need to get from source code to object code to an executable. GCC gives us a way to insert our part of the source code into that overall framework. And this is how our piece is organized. We have, as you can imagine, COBOL inputs and what are called copybooks. Those are include files, command line options, ta-da, so it goes into a compiler. That compiler has a parser. I was told that you're not supposed to use YAC, that all the important compilers do it with their own recursive descent tree algorithm. It wasn't my experience. I'm glad we're using Bison as the parser. This gets handed off to the other part of the project from my point of view, what we call the code generation. We build what's known as a generic tree. We hand that off to the magic inside GCC, and out comes the system. So from my point of view, the lower level here is how the system works. We build generic, and then magic happens. The GNU COBOL compiler that I referred to earlier is a transpiler. It produces C code, and for the most part is used to invoke GCC to produce the result. The most difficult part about that, from a technical point of view, is that if you produce C and compile it, the debugging information that went into the executable reflects the C. So now you need a way to get from the C debug information back to the COBOL if you want to do source level debugging. We did that, actually. You can use it. It's a driver. It takes advantage of the GDB machine level interface, machine MI, it's called. And using that Python mediator, you get pretty good representation. But we wanted something that was direct. And we think we'll be able to produce things that's more efficient too. The process that we're part of is driven entirely by what people tell us to do. That's another reason not to write a compiler. And as I get feedback, as we get feedback, we use those things to drive what's important. Learned last year that XML handling is well, I didn't learn. I knew that XML was important to financial operations, to banks and things. What I learned is that they're using COBOL and they need an interface. So we are using IBM's specification for adding XML support. But in the last year, this issue of the being able to support Unicode encodings for national character sets, that's been added to the system. So the GCC COBOL effort is the first successful example of a complete COBOL compiler which goes directly to object code. I am quite sure from the work that's going on in the background that if I come next year to talk about this, I'll be able to tell you there are applications in production using GCC COBOL. That's been what we wanted to do, and we want a lot more of that, so it pays for these things. And I would like to thank you for your time. I see one question. Is this one?
Now that you have a compiler, do you have any ambitions to affect the language itself, like becoming a de facto ISO COBOL organization?
Thank you, yes. I'm not sure, I personally, yours truly, has the time to participate in the ISO process directly as a member, but it is something that we're considering as a firm. I am in contact with the people who work on that, on the committee, the working group, and have reviewed some of the upcoming specification, the draft report. the specific, there's a proposal now to add macro support to COBOL, a little bit like the preprocessor in C. Everything is a little bit like the preprocessor in C. I would like to think that the feedback I offered them was helpful. They did thank me. So yes, maybe. Actually, it may also be the case that we will push ISO in certain ways because we will have an implementation that does things. And it could be the case that we will do things that we would like ISO to adopt as part of the standard. I don't know. The utility of the compiler is determined by the people who use it. If we do things that are useful to the users that aren't part of the standard, then it's not clear to me that's the fault of the users. So I would say if we do things that are outside the standard and are useful, maybe the standard should consider adopting them.
Thank you for your talk. I'm a bit interested in how much new code is written in COBOL today, as compared to all the banks that has old code to maintain.
I don't know the answer to your question. The applications that have come to us are existing applications that are being moved either off the mainframe directly or off the walled garden of mainframe emulations on the PC. To the extent those are new programs, I'm unaware of people actually working on new code for them. So maybe that's the answer, 0. I don't think 0 is really the answer. I think it comes out of view.
Thank you for your talk. I was wondering, what are the differences between the different COBOL dialects?
Oh my goodness, how much time do you have?
About 30 minutes.
There are 2 big gorillas in the COBOL business. Maybe there are more, but there are 2 that I know. One is IBM, of course. The other has been known as Micro Focus COBOL for many decades. It was bought by Rocket Software recently. Micro Focus COBOL is itself an amalgam of different COBOL compilers. And a lot of the features, we talked about standards a moment ago, a lot of the features in Micro Focus COBOL exist because the standard didn't embrace them when the problem manifested itself. An example of that are constants. It's funny that we call variables constants, isn't it? So, Micro Focus COBOL supports a thing called one of the numbers. The records in COBOL data definitions have numbers. And one of the special numbers is 77. That means the top level number that doesn't have any members. Micro Focus went ahead and chose 78 to represent constants. They also have a specific way that they deal with the what's called the compiler directing facility, which is kind of a much more complex version of the C preprocessor. So those features had to be added if the system was to be useful to people who have Micro Focus COBOL. And as it happens, some of the early interest in GCC COBOL came from places that were using Micro Focus COBOL. So it was necessary over my still standing body to get these things to work on our system. And so the preprocessor definitions, the compiler directing facility that Micro Focus describes, and the level 78 constants are now part of GCC. In fact, we have people working on what's known as the runtime library that Micro Focus supplies. I've talked for a little while today about record-oriented access. the difficulty is that not all the world is organized as records, and we have files that are organized as byte streams, and you'd like to be able to access those files. And indeed, Micro Focus supplies a set of libraries functions to do that. You would think they would just offer you the POSIX interface, but they don't. Why should they? So we are adapting their definition of those functions to POSIX and are writing POSIX bindings so that we can write those things in terms of COBOL. And all of this is in the interest of getting Micro Focus COBOL applications to compile under GCC.
What does the migration journey from mainframe COBOL to using GCC COBOL actually look like in practice? I imagine it's not just copy this directory, move the files over, and boot up the other binary.
You imagine correctly.
Yeah.
I'm not sure I am the best person to answer that question. The problems that come to me involve the compiler. We do have a project on the shelf of the beginnings of a JCL interpreter, for example. The idea was that you'd be able to take your JCL and in the same way that we could adapt mainframe COBOL to Linux, we could adapt JCL to the shell. And in my opinion, there's no good answer for that yet today in the market. It's also not clear anybody cares. It seems to be the case. I've tried to interest people in using this and in developing it. But it seems to be the case that if we're going to take the job stream off the mainframe, we don't want to replicate the JCL environment that drove it. We'd rather rewrite that. But that's an example. Another example is CICS. That has a good answer. There's a product out there called OpenKix that is good emulation for CICS. A third example is something I wrote, which is an IMS emulation. Many COBOL applications rely on that kind of on IMS, and again, there's no good commercial replacement for it or open source replacement. So now, well, there is. It's mine, but it's not in use. For another example is RACF, and we don't think there's a use for a reason to use RACF or replicate it in the Unix environment. So again, the security is provided by native means. So each of these things has to be addressed in turn. And I hope that I'll be able to convince one of those fellows to come here next year and tell you more about that, because I think it's an interesting question.
Any more questions?
I see two, or one.
I guess this is more on the runtime side, but how do you handle, for example, reliability with storage, with COBOL specifically? For example, file corruption, since that is now handled by the runtime, instead of being handled by the compiler side, that will be handled by the user.
If your file is corrupted, there's no chance the compiler is going to notice. Whatever gets read into the defined buffer for that record, that has to be correct. The compiler will prevent you from reading the wrong kind of file. It won't let you try to access by key a file that doesn't have a key. But once you leave that restriction, if the data in the file don't agree with what the application is programmed to expect, hilarity will ensue. There's really no way for the compiler to prevent what will come next.
maybe this is slightly off topic, but if organizations want to migrate to GCC COBOL, what are like the common practices around testing? Do they typically have unit tests or something to detect if it actually works as expected, or is it a lot of gambling for the organizations that try to migrate?
Can it be both?
Yes.
Yeah. I think because each environment is very different, I don't think there's one answer to your question. They have some definition of working. They have some similar testing environment that emulates the production environment in some way, and they test it to their satisfaction. They don't clear it with me, so I don't know more detail than that. I can't think of anyone who's described to me the testing structure or framework that they're working in.
Me again. So to answer that question a bit, I participated in a migration effort a couple of years back where we moved from COBOL code to Java. And the way that was done was that we wrote emulators for the code so that they would produce the exact same records, which meant that testing was really simple, it's just comparing the resulting text files. So that was the easiest testing framework I ever worked with, actually.
Any more questions? Well, I would like to thank you, Jens.
Can you hear me? Good morning. If you'll indulge me for just a minute, I'd like to introduce myself to the Swedes in the audience. Det var för 50 år sedan kom jag första gången till Sverige, till Jönköping. Jag visste inte på den tiden att COBOL och jag är född samma året. Vi säger är född därför att jag står här nu och COBOL får ju med. Eller tvärtom, jag vet inte. Så jag skulle säga till dig, om du tänker om framtiden, vi skulle veta att framtiden är någonstans konstigt. Thank you.